Good day, viewers. Welcome back to Aliphatic Teaches. Today in our mathematics class, we are going to be talking about the continuation of our Pythagoras theorem. That is the application of Pythagoras theorem. Example 1. In the figure below, calculate line AD to the nearest millimeter. Looking at this triangle given to us, we are going to see that we have two triangles here. Triangle ABC and as well triangle DBC. These are the two triangles we have here. Now, but to calculate line AD, this line AD here doesn't have a special triangle, meaning that it's not a right angle triangle. So in this case, we have to find a way of getting line AB. When we get line to get line AB, then we get our line AD, then we subtract to get our line AD. Now let's go by this way. Don't forget, in our last class, I explained that you must be given two sides before you can make use of Pythagoras theorem. Now let's go by this. Triangle ABC. We are given this line. We are not given this line AB. So we can take out line ABC. Likewise, we can take out line DBC because we'll be having line DC to be 5 cm, BC to be 4 cm, and we can calculate our line DB. Anyway, take out our line triangle DBC. Let's take it out. In triangle DBC, don't forget your angle is at the center. When you take out triangle DBC, we have the triangle this way. So DBC. So DC is 5 cm, while this one is 4 cm. So we want to find DB. Let's call it X. So when we call it X, don't forget this box where it's facing is our hypotenuse side. So Pythagoras theorem states the square of the hypotenuse side. The hypotenuse side is line DC square equals to the sum of the squares of the two opposite sides, line BC square plus line DB square. Now our line DC is 5 square, line BC 4 square plus DB S square. So this is 25 is equals to 16 plus S square. Now let's collect like time, or 16 comes here. We have 25 minus 16 is equals to S square. Our unknown must be to the left hand side. S square is equals to. So when we have 25, take away 16 from 25. So it's going to give us 9. So that is 9. Now to get my square, my X, I have to square root both sides to get rid of this square. So square root of S square is equals to square root of 9. Square cancels square roots. So the value of my X here is equals to 3 cm. Now in this case, and our S is representing line DB. So line DB equals to 3 cm. Now we are able to get our line DB to be 3 cm. So from here, let us now calculate our line AB because AD cannot be calculated. Now we take out this triangle in triangle ABC. Now in that triangle, we take out the triangle ABC. So this place now is 6 cm, our AC. Then BC 4 cm. Now let's call this place Y. So this is our hypotenuse side. The square of the hypotenuse side, line AC square, is equal to the sum of the squares of the two opposite sides, line AB square plus line BC square. So let's apply line AC, C square, is equal to line AB, Y square, plus line BC, 4 square. So here we have 36 equals to Y square plus 16. So collect like term. So this comes here. I have 36 minus 16 is equal to Y square. So when you take away 16 from 36, we are going to have 20. Let's say our y square is equals to 20. The next one is to find the square root of, to get the square root of both sides. So square root of y square is equals to square root of 20. So square cancels square roots. So I want to get the value of my y. By pressing your calculator, your y equals to 4.47 centimeter. Now that is the value of our y, and our y means line AB, and line AB equals to 4.47 centimeter. So that's our line AB. Now since we are able to get our line AB and our line DC, and we now need line AD, so the next thing is to subtract. You take away these three from the whole length to give us this place. Now let's look at this. Our line AB will equals to line AD plus line DB, because the whole length here means addition of this and this. So if you get that, so we now have our line AB given as 4.47. Because our line AD is what we are to calculate. Line AD plus our line DB, what we've gotten before, that is 3. So collect like time. So we have 4.47 minus 3 equals to line AD. So our line AD, so when you take away 3 from 4.47, so we have what? We have, take away 3 from 4.47, we have 1.47 centimeter. But we are told to find our answer to the nearest millimeter, and don't forget, 1 centimeter will equals to 10 millimeter. If 1 centimeter equals to 10 millimeter, definitely our final answer here, which is our line AD, will equals to 1.47 multiplied by 10, that is 14.7 millimeter. To the nearest millimeter means we don't need a decimal point in this place. So look at the digits after decimal points. If it is between 5 to 9, you round up to 1. If it is between 1 to 4, you round down to 0. Now, this point, we have 7 here. So this 7 will be rounded up to 1. Add the 1 to this 14, making what? 15. So we have 15 millimeter. That is our line AD. Example 2 reads thus: find the values of x and y in the figure below. So we have this figure. The first thing is to determine how many triangles do we have here. Of course, we have 2. And don't forget, your angle will be at the center. We have triangle ADB and triangle BDC or CDB. Just make sure that this B is at the center. I want to find the value of x and to find the value of y. Which one are we going to find first? Let's go back to the rule I gave to you in our first lesson, is that before you can use Pythagoras theorem, 2 sides must be given. 2 sides must be given in a right angle triangle. Look at this triangle BDA. We have this side and we have this side. Definitely, the first thing to calculate is x. You can't calculate y because in this triangle BDC, we are given only 18 centimeter. We don't know y, we don't know x. So in this case, let us take in triangle ADB. So in triangle ADB, let's take out the triangle. So this is B, D, A. So this is 10 centimeter, 26 centimeter, and this is value x. So we want to find the value of x now. Now, to find the value of x, the square of the hypotenuse, let us identify the hypotenuse side. Line AB is the hypotenuse side. The square of the hypotenuse sides equals to the sum of the squares of the 2 opposite sides, line AD square plus line BD square. So line AB is 26 square equals to line AD 10 square plus line BD x square. Now, when you put our calculating machine, 26 square give us 676 is equals to 10 square 100 plus x square. The next thing is to collect like times. Let this come here. Don't forget, in our rule of signs, there's a positive sign here. So anytime the positive sign is crossing equals to, you change to negative. So we have 676 minus 100 is equal to s squared. So when we take it away, we have 576 equals to s squared. So let us put the unknown to the left. S squared equals to 576. Then we now square root both sides. Square root both sides. Square root of this. Square root of this. This cancel this. So square cancel square roots. So we have x equals to. So square root of 576. When you press your calculator, we have 25.8 centimeter. So definitely our value of x is 25.8 centimeter. Now, since we are able to get the value of x here to be 25.8 centimeter, so it should be easier for us to get y because we have been given two values now. Now, in triangle BDC, so let's take that one out. BDC. So this one is 18 centimeter. So this place is 25.8 centimeter. We can get our y now. Now, our hypotenuse first. This is the square of the hypotenuse size. The hypotenuse size is line BC square equals to the squares, sum of the squares of the two opposite sides. So, line BD square plus line DC square, line DC square. So, line BC is y square is equal to line BD 25.8 square plus line DC 18 square. So we have y square equals to, so when we press the calculator, 25.8 square gives us, that is 665.64, 665.64 plus, so our 18 square also give us 324. Then y square equals to, when we add up the two, we have 989.64. 989.64. So the next thing is to square root both sides. So square root of y square is equal to square root of 989.64. Square cancels square root. So my y, so when you also press a calculator to get the value, we have 31.46. 31.46, which can be approximated to 31.5 to what? 3 significant figures, or to 1 decimal place. So this is the application of Pythagoras theorem. If you are a new member and you find value in this, kindly subscribe to my YouTube channel and share to other learners to also benefit. If you are our usual member, I say thank you for believing in me. I meet you in the next class in order to discuss word problem in Pythagoras theorem. Thank you very much.